list, your information in list 1, and you have your distances in list 2. I'm just going to talk about what this problem's about before we get started. Make sure we know what's happening. This is a study of the legibility and the visibility of highway signs and that relationship to age. Okay? So Pennsylvania Research Firm determined that the maximum distance at which each of 30 drivers could read a newly designed sign. And so then they studied that range for those participants from 18 to 82, and they were wanting to examine the relationship between age and sign legibility distance. So if you were just to kind of guess what's happening in this context, what do you think is going to happen with your sign legibility as you age? The distance will probably what? You think as you get older, your distance you can see will increase? Probably decrease. Correct. So perhaps your aging eyes will be able to see less. Okay. So I wrote down everything on this. I don't want to take the time to do this phantoms model down here, so we're going to zip through that. But you are going to use your information in L1 and L2 for something on the next page. So here we go. First question is there a linear relationship? Okay. So what can give us evidence of a linear relationship? How do we get evidence of there being a linear relationship or there not being a linear relationship? What do you have to do? Run a hypothesis test. Okay, good. That's our phantoms. So we're going to run a hypothesis test so we can say, ta-da, there is a relationship that's linear, or there's not a relationship, so we're done. Okay, so here we go. All right, first thing of phantoms. Beta is the slope of the relationship. Slope of the relationship between all drivers' age and their distance that the sign can read. Here's our hypothesis statements. The null is that the slope is 0. And again, you don't have to write this down. I'll put this online, but I want to zip through this and just kind of follow phantoms with me. The alternative is that the slope is not equal to 0. Okay, so what comes next after P and H? A is your assumptions. Here they are. Linearity is the first one, and from my graph and the fact that my R value is -0.8, do I have reason to believe that linearity is possible? Is it worth pursuing? Yes. Independence is the next one, and I would say that one driver's visibility is independent of the others. Okay, is that reasonable? How about random? That would have to be random drivers chosen would have to be then assumed because it wasn't stated. All right, what's our next condition? Nearly normal. So I looked at my probability plot, and again, on your calculator, you are going to get that from this last spot here. This right here will give you a normal probability plot. Okay, so your data's in there, and you could look at that. I did, and you want it to be linear. So this implies that we have a nearly normal that can be assumed. Okay, because we are dealing with normal model here. It's the t-curve, so it's nearly normal. It's not the chi-squared curve like before that was just one-sided. This is the t-curves. It's a linear regression t-test. And equal variance in the residual plot. So here it is. I showed a picture of it, and I forgot to write, but there is no fanning. So equal variance is good. So I'm ready to move on. What's next in my phantoms model? Name the test. The name of the test is linear regression t-test. What's next? The test statistics. I want to include all three of these. How did I get these three values here? The t-value, the p-value, and the degrees of freedom. Where did I find all of those? I ran the test. Okay, good. So I run it in my calculator, and I have left off that for you, but these are the results that I got. So now I'm going to obtain a p-value and compare it to alpha. So 0 is less than 0.05, so I make my decision and I reject the null. If you reject the null, what can you say about the alternative being true? You have evidence. that the alternative is true. So guess what? My stating the conclusion says there is evidence that there is a linear relationship. So, ta-da! I have evidence of a linear relationship, so guess what the next question is going to be? I wonder what? I wonder what that slope could be. That's the question that occurs next. I have run the test and I have evidence of a linear relationship, so now I wonder what that is. That's when you create a confidence interval for the slope. Okay, so turn the page over to this side. It actually is not technically the next question. Let's go through a couple of these quickly before we do that interval. Here is when you ran the test, the equation that came about. I want an interpretation of this slope of -3. So this says the sign legibility predicted sign legibility in feet equals 576.68 minus 3 times your age in years. So my question to you is, I need somebody to tell me the contextual meaning of this -3 slope. Okay, good. Close. How about for every 1 year age you increase, then the sign legibility distance decreases by about, because it's prediction, 3 feet. Okay, so on average, they're saying every year you get older, the distance you can see is 3 feet less. Okay, on average. Okay, so this right here, and you guys have in your L1 and L2 the data. So I want you all to compute the interval. It says determine a 95% confidence interval to estimate the true slope. So you go to your calculator and you go, where do you think you go to get an interval? It is it's a linear regression t interval, but where is that found in our calculator? The same place all of our tests are. Yes, stat over to test are all the tests and intervals. And look at the very bottom. F is linear regression t test, the thing I just ran. G is linear regression t interval. So you hit that, you have your X list is L1, your Y list is L2, you determine the sea level. What's sea level? Oh no, it's not, it's how far you are above. Okay, no, the confidence level, okay, regression equation you don't have to put in there, and you compute. Okay, so I want you to compute. I actually am not computing because I have different data in my calculator. Compute. See if you get this interval right here. -3.876 to -2.138. This is an estimate for the slope of the relationship between the two variables. So that's the range of plausible values for the slope. The entire plausible values are what sign? All of them are what? Negative. The entire interval is all negative. So does this give me further evidence that there really is a what? Good. This gives me further evidence that there really is a linear relationship. What would kind of blow that out the water and mess it all up? Yeah, if one of them was positive, meaning it crossed over from negative to positive. So look here. I have something in my calculator that does that. Watch this. Ta-da! -0.93, comma, +17. So the slope could be, according to what I have up there, it could be a little negative, or it could be pretty steeply positive. Wow. So if the slope can go from a negative to a positive, then what could it also be in that interval? It could also be zero slope. And if it can be zero slope, then what would that mean that we probably did with our hypothesis statements? What did we do with our null hypothesis? We don't have evidence of a linear relationship. Okay, guess what? Those will always go hand in hand. If you reject the null, then you're going to find an interval that doesn't contain 0. Okay? So they should, and if you do, you've done something wrong somewhere, and you probably need to like go back and check that. Okay? You hear what I'm saying? If you reject the null, you are saying linear model applies. So you should have something that does not contain 0 for your interval. If you have an interval that contains 0, the slope could be 0. And so when you ran your test, then what probably was the conclusion? What did we do with our null? Okay, what does failing to reject the null mean? We don't have evidence to conclude that the alternative is true. We do not have evidence that the alternative is true. So I do not have evidence of a linear relationship. If I fail to reject, I do not have evidence of a linear relationship. And that was confirmed by an interval that includes 0. Okay. So, with all that being said, by the way, let's not forget this little saying here. So, your interval says that you are 95% confident that the true slope of the relationship between age and sign distance legibility is between this and that. Okay, good. So that's basically half of what you need to know today. It is how to do this interval when you have a set of data that you have put into your lists. Okay? The second way that I want you to be able to get the interval is from a computer printout. So, from a computer printout like this, you do not have all of the data to put into your calculator. And if you do not have all of the data to put into your calculator, then you can't go min reg t interval in your calculator. You have to do this by hand. Okay? So, we have to do this by hand, so let's get started. Not too bad, because all of the numbers are here. You just have to know what you're looking for. So, in general, we should remember that an interval comes from your estimate. What are you estimating? This is a problem about estimating the not the confidence. No. Our confidence interval is an estimate of the slope. Good. This estimate is beta. That's your slope of your what? Sample. That's the slope of your sample. Okay? And what is this part here after the plus and minus? That is your margin of error. So we got beta, plus or minus. Critical value. This critical value for t-tests is what kind of critical value? A z-star, a t-star, or a chi-squared number? T-star. Do you remember how to get t-stars? Inverse t of 1 tail, comma, degrees of freedom. Okay. And now, times that by the standard deviation of your estimate. What is that? Standard deviation of the, what's our estimate? B. Very good. Standard deviation of the slope. Yay. So let's take that to the computer model and fill it in. So here we go. We have our computer model, B plus or minus t star times standard deviation of the slope. What is the sample slope according to our computer printout. That's the sample slope on our computer printout. Right here, negative 3.0068. I'm just going to call it negative 3.00, that's close. Okay? Plus or minus. Whoa. How do I get that? Okay, inverse T of what? One tail, I want you to be 95% confident, so what is in one tail? Okay, 0.025. What's the degrees of freedom? The degrees of freedom on this problem stem from 30 participants. So what's our degrees of freedom? Okay. On the front page. Okay. It's the same problem. Okay. Okay. Furthermore, it actually is located right here. The degrees of freedom right here is 28. Okay, so comma 28. Okay, so here I go. I'm going to find that on my calculator. Inverse T of 0.025, comma, degrees of freedom. 2.048. Now it gives me the negative version, but what do I need to account for that negative version? No, because this plus and minus does that for me, so 2.048. Okay, parentheses, standard deviation of the slope, where is that? Good, it's right here under standard error coefficient. It's on our slope line. Remember that our slope line is this whole line right here. Okay, so 0.4243, and guess what? If I do the algebra for that, I come up with negative 3.876 on the negative 2.138, and that is the same thing that I got when I had the individual data and I could do it in my calculator. So you have two methods to go about here. Method number one, you have the individual data. You can plug it in your calculator. You have the list of data. You can plug it into your calculator to get your interval. Method number two, you have the computer printout, so you have to do the formula by hand. Do you see why I cannot just show you everything shortcut in the calculator? Now, I need to explain to you that on your homework, so please turn to your homework. I want to talk to you about this page. You have 4 problems. Problem number 1 addresses individual data. Hands up. So, I tell you what, I want you to just do number 1 and 2, and I want you to do problems E and F. F is an added problem. It's a 95% confidence interval for the estimate of the slope. So do E and F for problem 1 and problem 2. Okay, goodbye.